For problem number 8, we can see that Shaniqua and Beatrice throw a grape in the air. You can see the height of Shaniqua's grape given by this function, given by this graph, and it looks like Shaniqua, her grape went 110, let's see, height in feet. So this is the height in feet. Hers went about 110 feet in the air. Looks like the vertex is right around 110, something like that, or close. And then it looks like the height of, or the time that Shaniqua's grape was in the air is about 6.2 seconds. So just looking at the graph, the height being 0, time in the air, the time, so this is time, and that's in seconds. All right, so h of t and then t. Well, we then are given Beatrice, her equation for the height of her grape is given by this equation. So if we want to know how high hers went, we better find the vertex. So the vertex is at, well, we have to find the t coordinate of the vertex. That's negative b over 2a. And again, a is negative 16. B is 32, and we don't need the C, but we'll put it down anyway. Negative B over 2A is negative 32 over 2 times negative 16. So negative 32 divided by negative 32, that's just 1. So the x coordinate of the or t coordinate of the vertex is 1. So somewhere on this vertical line, Beatrice's grape, we'll see how high it went. And so if we wanted to find the height at time 1, we would get negative 16 times 1 squared plus 32 times, make sure you can see it, 32 times 1 plus 4. So negative 16 times 1 squared is negative 16, plus 32 times 1 is plus 32, plus 4. 32 minus 16 is 16, 16 plus 4 is 20. So that's the height of Beatrice's grape. So since 10 is here, then 20 must be somewhere right here. Let me do it in a different color. So that's my ice machine, in case you're wondering. And at time 0, Beatrice's grape was 4 feet high. And so her grape went up like this, and then came down perhaps somewhere just to the right of 2. Alright, it's like 4 feet high at time t equals 2, and then time 2 point whatever. So her grape didn't go very high in the air at all. So we can see that. But it says, let's follow the instructions. Construct a graph of the height of Beatrice's throw as a function of time on the same set of axes. So we did that. Please label the player's name beside each graph. So this is Beatrice. And this one over here is Shaniqua. Got it. So we can clearly see that Shaniqua's grape went higher than Beatrice's grape. And we did that one. So that's 3 points. 1 point for the graph being in the right spot, vertex at 120, and actually 2 points for the graph, 1 point for the names. So that's 3 points right there. And then let's see, approximately how long is each person's grape airborne? Explain your reasoning and or show your work. Well, clearly Shaniqua's grape was in the air for approximately 6.2 seconds by observing the graph, and specifically the graph's t-intercept when the height equals 0. So that's what we really want to make sure you know, is that when the height is 0, that's when the grape hits the ground, and the grape hits the ground at a certain time. That time is about 6.2 seconds. So that you get 2 points for just doing that. And then you've got Beatrice. Now, the h of t equaling 0 for Beatrice, we've got to solve this equation. We've got to solve 0 equals negative 16 t squared plus 32t plus 4. Hopefully you don't start here and use the quadratic formula. Hopefully you can see that it would be wise to go ahead and divide both sides by a negative 4. I put 4 initially, but I really like it when my t squared term is positive. So I'm going to go ahead and I'm going to divide every term by negative 4, and I get 4t squared, and then over here minus, got to be careful, minus 8t minus 1. It does not look like it factors, and so what we're going to do is we're going to use the quadratic formula, and I'm running out of room here, but let's see if we can fit it in. Let's just see. So quadratic formula, we're going to let a equal 4, b equal negative 8, and c is equal to negative 1. So b squared minus 4ac, we get b squared, which is 64, minus 4 times a, which is 4, times c, which is negative 1. So we have 64, careful, minus minus is plus 16, and that makes 80. So that's not too bad. Storage almost full. Okay, I'm not sure if I had to pause there or not. Okay, we're almost full here. We've got to get going. So 80 is the discriminant. Let's do the rest of the work down here. So t equals, so this is the work for up here, t equals the opposite of b, 8, plus or minus the square root of 80 over 2a. Now, 80 can be rewritten as 16 times 5, and so the square root of 80 is 4 radical 5, and 2 times 4 is 8. So we have the ability to go ahead and factor out of 4, and we get 2 plus or minus radical 5 over 8. 4 goes into 4 once and into 8 twice, and so we get 2 plus or minus radical 5 over 2. So if you think about it, 2 minus radical 5 is going to be a negative number. So that's not going to do us any good. We can see that the positive side over here is 2 plus radical 5 over 2. So therefore, Beatrice's ball was in the air. Beatrice's grape in the air for 2 plus radical 5. Don't put plus or minus. It doesn't make any sense. Seconds. And you can see all the work right there, and I'll be able to see that as well. So that's 2 more points. I'm going to stop the video now and do part C, just in case it stops on me. Yeah.